Hi, welcome to the last day of our first Math Meets Arts Festival. I'm sorry about that. So today we will be talking about math and creativity, and we in today's session we have sort of a teaser for the events in the evening. So let me just sort of introduce what the idea about this theme is. Math and creativity is the question: how much are mathematicians using what they are in their daily work? How much are they using creativity, and is what they're doing somehow related to art? So we will start with a video by Lee Allison, who has done a work on 3 drum pieces on a topic in differential geometry, which is called the finite topology conjecture. So to give you a little bit of background, so what we're looking at is a minimal surface is something which can be made out of soap film. So here's one example of such a thing. So you see this one is already sort of complicated. It has sort of different layers. And because this is just sort of a model, you have to imagine that it's sort of continuing at these ends. It's just continuing upwards and downwards. And the question is sort of, how do these guys look like? What is the minimal surface? How can they behave? And this particular conjecture we are looking at is the finite topology conjecture, which is asking the question, if you, for example, take a pretzel, so you have this thing and you're taking 10 points on this pretzel and try to move them out to infinity. So in our example here, these planes go out to infinity. So they would continue in this direction. So the question is, can you do this? Take a pretzel, take sort of 10 points and try to move them out to infinity. And the question is, can you do this without getting the surface to self-intersect? And can you do this while the surface, or so that the surface at the end becomes a minimal surface? And this is the topic this following video of Lee Allison is. It's called Infinite Items, and it's the topic conjecture. So can we see that, please? So this is sort of the response of Lee to a very specific question in mathematics and how creativity is used there. Let's just go ahead and have a look at a quick at a discussion between mathematicians on that. We will now finish the conversation for now. I hope you will join us. The whole project about math meets art started a long time ago when I thought about things, ways how we could explain mathematics to a non-expert audience. And one of the topics we started out working on, and which you have seen in the video, is about a well-known conjecture in minimal surface theory, because I thought it would be very helpful to have something which is not a resolved question or where we already know the answer, but something where the artists we would be working with also could see that there is a bit of creativity involved in doing mathematical research, because there's a question around and we need to find, first of all, there is a process of finding this question, and then there's the question about how to approach such a problem from the point of view of mathematics. And having this as a starting point, we were thinking about how we can show this to an audience, how a mathematician works and what their daily life is, so to speak, rather than just showing a result of a particular research. So maybe Jenny can respond to that.
So I'm muted. I suppose one of the things when I applied to be part of the project was I really liked the idea of actually being able to explore the mathematician's brain and see what happens inside there, which was very much why I chose to kind of use things like UV and glow-in-the-dark filament for the installation, and torches, so you could literally kind of like climb inside, you know, the brain and see what's happening in there. So, but actually the word, I think the whole phrase, the finite topology conjecture, was quite inaccessible, if I'm honest, in the beginning. But then as I slowly obviously I knew what finite meant. Topology I was not so sure about, and conjecture I had no clue what that meant. So, you know, as I've learned to decode that word, my take on that word would be hypothesis. Does anyone have a response to that, or how would you frame that idea?
I could say something to that. I'd say it would just be a question you don't know the answer to. Yeah, so just an open question. And I think from the mathematician's point of view, it's a way to get into the artistic side of things too, because mathematics is, in part, it's a logical collection of true and false statements. But it's not just that. It's a choice of problem to work on. It's a choice of direction to go in. It's a choice of way to build up a structure, a mathematical structure. And it's very artistic and very subjective. And I think from the mathematician's point of view, that makes us interested in artistic aspects of things. Should I throw the ball to somebody else?
Can I also say that, yeah, it's interesting to see there's a creative aspect to what questions mathematicians choose to ask, because I guess there's a lot of variety out there, and also what questions artists choose to ask as well. So that's a creative aspect in itself, but also what I found throughout the process in this project is that there's always that flexibility, because it's a hypothesis and you don't have 100% proof. There's a flexibility to change your mind and backtrack, and there's a freedom to that I think is very unique to the arts and the sciences. So you constantly have to reevaluate your thoughts and your perspective.
I agree with Chloe and what she said, but let me also have a sort of a different perspective of what a conjecture is for me. At least from a mathematical point of view, I think that a conjecture is somehow one of these revealed truth that somehow is something that is true on the nose that everyone feels it should work, but somehow we have no idea why. And this big conjecture tries to unveil somehow the deep machinery which is going behind these truths that everyone sort of agrees with. And there is a lot of creativity in trying to say why this is true, right? I mean, or for instance, when these conjectures are not true, because it happens often as well, there is a lot of creativity in actually building up the examples that shows that your conjecture was not true. I mean, there are really amazing objects that are built in order to prove that a conjecture is false.
So sometimes actually trying to prove it false might be part of the process, and actually it's not always proving its truth is where the progress comes in. It's like asking the right questions to kind of, and to disprove the theories or the hypotheses that have come before that. So actually, you know, both ways are really progressive, and that's really cool. And it's almost like, how many times can we disprove something before we find something that we can't disprove? You know, that's a really interesting way of looking at it, rather than being like, yes, this must be the way and I'll show you why. You know, whereas actually you're just like, no, that's not right. No, neither is that, neither is that. No, that's not right. No, but you know what else isn't right? This, you know, it's like really interesting.
Actually, it's quite fun to get it wrong. Yeah, and then find out that you're wrong.
Yeah.
Mm-hmm.
And also I feel that along the time in the life of some conjecture, I mean, the community changed its mind. At first, everyone is saying, yeah, this should be true, of course, and everyone tried to do it. No one actually found a proof, and then everyone is saying, no, this is wrong. I mean, the conjecture should be false, and I think this is why, and try to build an example, and does it work? And then there is some result coming somewhere and saying, oh, yeah, no, in fact, this gives more evidence towards the conjecture. And actually, there is a lot of dance, if you want, going from one perspective to the other, to the falseness or the correctness of these different conjectures.
Yeah, so in this sense,
sorry, Katrin, I've always thought the two disciplines are really similar in the way that they're both seeking the truth. So it's almost like reality is the conjecture. Mathematicians and scientists seem to use their art or their skills to describe the universe, whereas the artists are just using similar skills to describe maybe the internal universe. But I always thought the conjecture, the sort of truth that you're looking for, we're both trying to sort of find the facts to fill in the gaps of the conjecture, which is sort of the larger reality. But yeah, I think our two disciplines are very similar in that we approach it looking towards trying to fill in the gaps to find that absolute truth. I think we're both very similar, coming at it from sort of opposite ends, if that makes sense.
Mm-hmm. Jenny, you were just about to say something?
I can't remember now.
Okay, so yeah, I think we found out through this work together that we actually have sort of a lot of common things around this topic of conjecture even, so we can sort of understand that mathematical concept both from the math point of view but also from the artistic point of view. And I think this is sort of really interesting how these two things are sort of connected to each other. And I think we will now finish the conversation for now. I hope you will join us later on in the evening where we have more discussions of that type. So thank you very much. So yeah, just as always, we would like you to look at our survey and give us feedback on what you thought about the event and how you think we should proceed with our work and what ideas you found particularly exciting, and we would be really appreciating your feedback on that. With that, I just want to show quickly again the slide of the evening events. So tonight we're going to have the two missing pieces of the infinite items, and we're going to have 4 talks of mathematicians, really short talks, but they will talk about their research and how they think that they use creativity in their work. And again, we will have a longer discussion about the activities. So thank you for joining us today. Hope to see you later on in the evening. Bye for now.